Hello everyone. With this video, I'd like to let you know about HPLC, high performance liquid chromatography technique. This is the most widely used technique for the separation, identification, and as well as quantification of biological bioactive compounds, and also it's possible to identify pure compound either from microalgae or other biological compounds like a pigment, lipid, phenolics, and antioxidant. The basic principle of HPLC is based on the differential interaction of compounds between its stationary phase and a mobile phase. The key concept of HPLC system involves there is a liquid mobile phase that carry a sample along with it so that it when it pass through the packed column stationary phase and it will differentiate compounds while interacting with the stationary phase at a different time based on the retention time and the formed peaks during the retention time. It will allow to separate the compounds with a different retention time. So normally in HPLC system there are different parts which play a crucial role for the HPLC principle to separate the compounds based on its retention times. For initial, I like to let you know the sample reservoir which collect which hold the sample which is in mobile phase, um, and there will be a pump which will help to push the compound or sample at a different pressure up to like a 400 bar, and there will be an injector to inject a sample inside the HPLC column and introduce sample. So usually as a stationary phase inside the HPLC system there will be a column which is made up of or which consists of a C18 silica pack system that will help to separate the compounds based on its polarity and non-polarity. Polarity there will be a detector system to separate compounds based on its retention time. There will be detect system like a UV spectrum system, mass spectrometry system for based on the different wavelength and mass and charge ratio. It is possible. So there will be a system of to record the graph which is known as a chromatogram. Based on it we can see the different peaks and graphs in the HPLC system through the screen, so we can separate. Normally the stationary phase in a HPLC system C18 column which is the silica, and this is non-polar, and this will be inside the HPLC system. And the mobile phase where we will use like a solvent like water and acetronitrile organic compound, chemical compound with we use organic solvent that we wish to separate. For that we have to make a different strength of organic solvent for the separation. In practical, like for example, if we wish to separate microalgae bioactive compounds like carotenoids or phenolics compound, in that situation we need like a HPLC system, yes, and the solvents like acetonitrile, water like milky water, DN is freeze water, and formic acid. In the equipment like system like HPLC system, normally with the we need centrifuge, sonicator, rotary evaporator, syringe filter, and analytical balance. So they have a different purpose. Initially, we need to separate. Mm, we need to separate a microalgae sample, or we need to have a biomass of microalgae, so that initial step includes the centrifugation of microalgae at a different speed. Normally we can do like a 5000 rpm for the separation of a microalgae biomass using centrifuge for 10 minutes. Then we will have like a palette of microalgae, and we can mix with the distilled water, and we can again separate the compound and put or we can freeze dry that. After freeze drying for some time, if we wish to like carry out the SPLC experiment later, then we can put for some days. But if we want to immediate extraction of bioactive compound, in that situation we can take like normally 50 microgram of dried biomass of freeze dried sample, and we can make a solution from that biomass with methanol. We can use like a 5 ml of methanol, and we will do sonication for the break or to um, broke the cells. So sonicate for some time, and like 30 minutes it would be sufficient at temperature less than 30 degrees centigrade. Afterwards, we will after sonication we will separate compounds again with the centrifuge with the 10,000 rpm, and we will have a palette and supernatant. We will use a supernatant, and we will go for the filtration with using syringe filter with the diameter of 0.2 micrometer. So now this will be the sample for the HPLC system. So we will conduct like a reverse phase HPLC. So normally we perform this experiment at a 30 degree centigrade with our mobile phase will be like a solvent water with 0.1% of a formic acid, and in the solvent B there will be like acetonitrile or methanol, and we will have sample. Beside that we set the flow rate of a solvent uh, through the column at 1 milliliter per minute, and the injection volume will be 20 microliter, and there will be a connected detector system like UV spectrometry, or like we will have mass spectrometry for that. For the measurement of compounds like carotenoids, normally we measure the wavelength at a 450 nanometer, while as for the phenolic compound, we normally seek at 280 nanometer. So, um, on preparing a sample with a uh, different solvent concentration, like with water and organic solvent are different concentration, uh, we will have a fraction of sample which we will run through the HPLC system, and observe the peak on the chromatogram. Then there will we will have a different retention time. At the moment of collection of retention time and the graph in the chromatogram in our HPLC system, there will be a fractionation collector. That fractionation collector collect different compounds based on its based on its fraction the different retention time, and we will have a different compounds of a different of different retention time, and based on the standard we will have a like a analysis of a compound on which group it belongs. We will determine based on the standards. But normally we need to be aware about the light exposure of a compound. Normally we have to keep samples in cold. It is essential to maintain the compound's quality, and also it is necessary to understand in the different situation we will have a different compound separation. So to separate compounds in it's a different fraction, normally we will look at the which compound is eluting first, and which compound is doing late in its elution. Normally if we have like a 5 minute of retention time with peak one, then we consider as a phenolic compound, and in case if retention time of 12 minutes, we consider as for the chlorophyll, and if we have like a retention time more, then we can consider it as normally for 18 minute carotenoid. So based on the facts, its retention time, we can determine the different compounds, and we collect those fraction based on its retention time in a fraction collected, and through the chromatogram graph, and we will collect different fraction compounds. And for the purification, during the fractionation collection, we will have a compound with a different retention time in the HPLC system automatically. uh, but during that time, there is also possibility of having solvent mixing or like a contamination. For the purification, we will perform a rotary evaporator, and that will help us to remove like a nitrogen evaporation, or even a solvent like water and other compounds, which is essential to separate a pure compound of from the separated compound. And we can determine even the compounds with a different mass and charge ratio with the mass spectrometry, even with the different wavelength normally for carotenoid 450 nanometer of wavelength to separate the compounds, whether it is carotenoid or not, which is very important. So and we have to perform the same protocol for the separation of those compounds, and it is important while doing HPLC system. Thank you so much for this video. I will be back with another new video with new details. Thank you so much. Please like, share, and subscribe for new update.